All right, today we're going to take a look at 2,2, the standard form of a quadratic function. So last week we talked about the vertex form of a quadratic function. Basically, you can have any quadratic function and it can be written in different formats to tell you different pieces of information. So last week we talked about the vertex form of a quadratic function, basically just telling you what the vertex is. You could look at it in vertex form and it'll just spit out. You could just pull out the information on where the vertex is at. If something's in standard form, similarly, you can pull out information from it just by looking at it, specifically the y-intercept. So let me see if I can find one here. This example right here, this is in standard form. So it's 4x squared minus 32x plus 69. A is up front, B is the coefficient to x, and C is the constant at the end. So your C value is always the y-intercept. So if I graph this parabola right here, if I went to Desmos and typed it in and graphed it, it would cross the y-axis at 69. Same thing with this example here. They started off in vertex form. They did some math to put it in standard form. I can look at this and my C value is just negative 27. So this parabola would cross the y-axis at negative 27. You can go back and forth between the two. So you can see these two examples right here are starting off in vertex form, and then they're doing the math to get it into standard form. So vertex form, if you remember, it's y equals a, parentheses, x minus h, parentheses, squared, plus k. And then standard form is just ax squared plus bx plus c. So you can go from one to the other just by doing a little bit of math. So in this example, they just use PEMDAS. So parentheses is the first step. You can't subtract 4 from x, so nothing inside parentheses can be done. Then exponents. So the next thing they did was they squared x minus 4. So they got 2x minus, it looks like they multiplied the 2 in there first. I think this problem maybe is a bad example because I think they're asking you what the mistake was. You can't multiply this 2 in first before you square it because you're not following PEMDAS. So let me go ahead and just show it to you real quick. I'll go ahead and work it out for you on a piece of paper. So if that's my vertex form, my first step would be to square x minus 4. So y equals 2. If I square x minus 4, typically what people do is they'll draw like a little box like that, and they'll do x minus 4 times x minus 4. Remember, x minus 4 squared, that's the same thing as x minus 4 times x minus 4. So whatever method you use to multiply it out, it doesn't matter. I typically do something like this. I won't use the box method. I'll just use the FOIL method. So first times first, outside times outside, inside times inside, last times last. So if you don't know the FOIL method, maybe Google that and watch a video on how to multiply a binomial using the FOIL method. So x minus 4 squared would be x squared minus 8x plus 16. And then I've got that plus 5 on the outside. So PEMDAS, parentheses, there's nothing to add. Then exponents. Now multiplication and division from left to right. So this is where I would distribute that 2. So I'd get y equals 2x squared minus 16x plus 32. And then now I would do the last step where you add and subtract from left to right. So we got a couple of like terms here. 32 plus 5 is 37. So 2x squared minus 16x plus 37. So I can start off with vertex form, follow PEMDAS, and put it in standard form if I wanted to. All right. So let's go down here with example 1 and check it out and see what it's asking us to do. So find the vertex form of quadratic function in standard form. So now we're going the opposite direction. So instead of the example I just showed you, going from vertex to standard, now we're going from standard to vertex. So they're telling you their example is just the generic algebraic definition of a quadratic, ax squared plus bx plus c. And they're just trying to show you algebraically how to find that vertex form, okay? So they're saying, here's an example where they start off with vertex form, and they do exactly what I just showed you. They squared x minus h, then they distributed a, and then you can add like terms. So this is a little bit confusing. It's because it's an algebraic definition, but if you want to look through that and try to track it, it's exactly like the example I just worked out on paper right here. So the easy way from going from standard to vertex, though, is that there's a formula, and that formula is right here. H equals negative b over 2a. So this is really important to have maybe down in a set of notes, because this is going to help us go from standard form to vertex form if you're asked to go in that direction. So notice they're telling you H, B, and A, that those letters are coming from standard form and vertex form. So in vertex form, H, that's the X value of your vertex. K, that's the Y value of your vertex. And then B and A is coming from standard form, which is right here. B is the coefficient to X, and A is the coefficient to x squared. So all you have to do to calculate the x value of your vertex, which they refer to as h, is just plug that A and B into this formula right here. So here's the example. What's the vertex of the function x squared minus 6x plus 10? So I'm going to go ahead and write this out on a piece of paper because I want to kind of emphasize some things here. So x squared minus 6x plus 10. So what's the vertex of this function? The important thing here is to know what a, b, and c are. So a is always that number in front of x squared. So in this case, that's a 1. And then b, that's always the number that's in front of x. So in this case, it's a negative 6. And then c is always the constant at the end, just a number that's being added at the end. So in this case, it's a 10. So our formula was h equals negative b over 2a. But when I do this, when I'm working through these problems, I think about this as the opposite of b over 2a. So that's how I calculate this, the opposite of b over 2 times a. So if you remember, you're dealing with a vertex. The vertex of a parabola is always that bottom point, or in this case, it's the highest point. So those are my vertexes. And the way we reference these are h comma k. That's the same exact thing as x and y. They just refer to the vertex as h and k instead of x and y. So in this case, it's h equals the opposite of b over 2a. In this case, b is negative 6, so the opposite of negative 6 is positive 6. The denominator, 2 times a is 1, so 2 times 1 is 2. So if I simplify that, my h value is going to be 3. Now, to calculate my k value, all I have to do is take that value for h and plug it into my function. Okay, so to calculate my k value, take that value for h that you just found and plug it into your function. So it's going to be 3 squared minus 6 times 3 plus 10. So 3 squared minus 6 times 3 plus 10. If you do the math, 3 squared is 9. Negative 6 times 3 is negative 18. So 9 minus 18 is negative 9. Negative 9 plus 10 is 1. So by using this formula, this thing is super important. Make sure you understand that because that'll give you the h value of your vertex. Once you know the h value, just take that number, plug it into your function, do the math, to get the k value. So the vertex of x squared minus 6x plus 10 is going to be at 3, 1. And that's exactly what this is asking. It's walking you through down here, exactly like what I just said. So step 1, step 2, calculate that h value. And then over on page 81, step 3 is to calculate the k value. So you can walk yourself through those steps there, but that's exactly like what we just did on paper. Example 2, graph a quadratic function in standard form. So they're going to give you a function in standard form, which in this case is x squared minus 4x plus 8. Again, they're just asking you identify A, B, and C, but there's some specific things we're going to pull from the standard form of this quadratic to be able to sketch this graph. Okay? So step 1, they're asking you to find the vertex. So we're going to do exactly like what we just did a second ago and calculate h and k. So for h, if you look at your problem, it looks like A is 1, B is -4, and C is 8. So to calculate our h value, remember that formula is the opposite of B divided by 2A. So in this case, B is -4, A is 1, so I'm going to plug it all in. The opposite of B, so the opposite of -4 is +4, divided by 2 times A. A is 1, so 2 times 1 is 2. So my h value of my vertex is 2. Remember, to get that k value, all you're going to do is go back and plug this in. So to get k, I'm going to take that quadratic and I'm going to plug in x equals 2. So it's going to be 2 squared minus 4 times 2 plus 8. And then do the math. 2 squared is 4. -4 times 2 is -8. So 4 minus 8 is -4. -4 plus 8 is +4. So I know my vertex is 2, 4. So step 1, done. Step 2, find the y-intercept. Well, remember, the easy way to do this is just to look at that standard form, and whatever that c value is, that's your y-intercept. So in this case, our our y value is 8. I don't know why I said y value. Our y-intercept is 8, because that's our c value. They're showing you there is an algebraic way of doing that. You can plug in x equals 0, and when you do that, just calculate everything where x equals 0, and it'll give you that your y-intercept is 8. But again, the quick and down and dirty easy way is just look at that standard form. Whatever your c value is, that's your y-intercept. So in this case, our y-intercept is 8. So I'm going to go ahead and write this as 0, 8, so it'll be a point. If you wanted to just put y-intercept is 8, that's fine too. Step 3, find a point that's symmetric to the y-intercept across the axis of symmetry. So one thing that hopefully you've seen before is if I have a quadratic, and just for the sake of making this easy to show, I'm going to keep my vertex at 0, 0. And then I'm going to say that this point right here is x equals 4. Okay? So if I have my y-intercept in that point there, well, we know that parabolas are symmetric. So I know that this other line that's off to the left, I could basically fold it across that y-axis and it would map, it would lay right on top of this side over here. So if this distance from my vertex to that point right there is a distance of 4, well, then I know that this distance on this side has to also be a distance of 4. So that'll give me a third point in this case. I've got the vertex, I've got one point, and because I know that they're symmetric across the vertex, that the left side has to map to the right side, they have to be the same distance away from the vertex, well, then I can find every other point. So for example, if this one was a 2 and that was given to me, I know that that distance is a distance of 2, so this distance has to be a distance of 2. All right. So find the point that's symmetric across the y-intercept. So let's kind of go ahead and sketch a graph of what we got so far. And when we say sketch, it's just a rough sketch. It doesn't have to be on graph paper. It doesn't have to be perfect. My y-intercept is 8. So there's my y-intercept. My vertex is at 2, 4. So we'll say this is 2. We'll say that that's 4. So 2, 4. Let's go back and look at this problem. It's positive x squared. So remember, positive parabolas smile. They're happy faces. Negative parabolas would frown, like a frowny face. So I know that this parabola has to be facing up, like a happy face, like this. Okay? So what they want you to do is calculate a third point. Remember, all parabolas are symmetric across that axis of symmetry. So across that line there, the left side will always map to the right side. Well, how far away is this point, this y-intercept, away from my vertex? My vertex is at 2, 4. So this is 0, this is 2. So that distance from my axis of symmetry to that is 2. So I know that this other point across that line has to be 2 away as well. It has to be equal, the same distance. So if our y-intercept was at 0, 8, our vertex right here was at 2, 4, I know that this other point across that line of symmetry, that line where it reflects across that same distance, well, 2 more units to the right, if that's 2, 4, it would have to be 4, right? 2 more to the right would have to be a 4. And this line straight across, it has to be an 8. So this is going to be that point. It's going to be 4, 8. Just keep in mind the big idea behind parabolas is that that line, that axis of symmetry goes through that vertex. So all of my distances to the left side have to be the same distance as the distance to the right side. So this point right here, if that distance was 3, then this point over here has to also be a distance of 3. So we're going to say this other point they're asking us to create is 4, 8. Let's just make sure that that's correct. Yep, right there, 4, 8. And now sketch the graph, which we already did. We had the vertex, we had one point, which was the y-intercept, and we knew because that line of axis of symmetry means that the distance has to be the same. The distance from the vertex to that point was a distance of 2. So the distance from the vertex to the other point has to also be a distance of 2. So 2 more to the vertex would take you to 4. And then on that line, y equals 8. So 4, 8 is your other point. Example 3. Interpret the graph of a quadratic function. So now they're just going to give you a graph, maybe a little background on it, and ask you to kind of pull some information from it. So the graph of this function, negative 10x squared plus 700x minus 6,000, shows the profit a company earns for selling headphones at different prices. What's the maximum profit the company can expect to earn? So looking at this graph, it looks like the cheapest they ever sold these headphones for was 10 bucks, right? That's a 10 right there. But that would mean they didn't make any money at all. So it must cost them $10 to make this set of headphones. If you look up here, it looks like they tried selling it for 60 bucks, but also, again, they didn't make any money, probably because they didn't sell any. So it takes 10 bucks to make them. They won't make any profit. And when they kick the price up to selling it for $60, they didn't make any profit, probably because they didn't sell them at all, right? Nobody bought them. They were just way too overpriced. But when they're asking you to find the maximum profit, what they're referring to is the vertex. So they want you to find the vertex of this problem. So we'll grab a piece of paper. We all know how to calculate the vertex from example number 1. And remember that formula for the vertex is opposite b over 2a. So in this case, our b value is positive 700. So the opposite of b is going to be negative 700. Divided by 2 times a is negative 10. So 2 times negative 10 is negative 20. And then simplify this. A negative divided by a negative is a positive. I can take a 0, reduce that down, and then 70 divided by 2 is 35. So I know the h value of my vertex is 35. Again, to calculate the k value, you're just going to plug in 35. So for k, it's going to be negative 10 times 35 squared plus 700 times 35 minus 6,000. Type that in a calculator, do it by hand, whatever you want to do. I think I'm going to cheat and just kind of look and see what they got for k. So h is 35. They plugged it in. They got 6250. Okay, so there's our k value. So what this means, this point right here, that highest point on that parabola, is basically saying that if you sell these headphones for a price of $35, so it puts us about right there, it looks like that's going to be the maximum profit of $62.50. So that's that sweet spot where they're selling it for $35. It's a quality product. That's a good price. And they're going to sell a lot of them. And that's the most amount of money they'll make. Example 4, write the equation of a parabola given 3 points. So what's the equation of parabola that passes through the points? Negative 2, 32, 1, 5, and 3, 17. They're showing you a method that's using matrices, which is the unit that we skipped. We decided not to do that. Well, we didn't. The district did. So we are going to use solving a system of equations. So you could see here in this example that they're taking each point that they're giving you, okay, each point, and they're plugging in the x and the y into this generic function, right? A generic quadratic is just ax squared plus bx plus c equals y. So what they're doing is plugging in x and y. So let's go ahead and do that. So for these 3 points, negative 2, 32, x is negative 2, y is 32. So it's going to be negative 2 plus bx, so b times negative 2. And then plus c, and that's going to equal 32. I like to put my y's on the right-hand sides. They for some reason write that on the left. So I like my y's on the right. And then the next point, so 1 comma 5. So x is 1, so it's a x squared plus bx plus c equals y. And then the next one, 3 and 17. So a 3 squared plus b times 3 plus c equals 17. So we're just taking what x and y equals and we're plugging it into each generic function. So now we're going to go ahead and simplify this. So negative 2 squared, I should have wrote that a little bit further to the left, but I'll go ahead and just kind of write these below it. Negative 2 squared is 4. B times negative 2 is just negative 2b. I like to write my coefficients up front, so I'll kind of flip-flop those two things. Plus c equals 32. 1 squared is just 1. So I'll have a squared. B times 1 is just b. C, and that equals 5. And then for our last one, 3 squared is 9. B times 3, C, 17. So let's make sure I didn't screw anything up. Make sure we got the same problems. 4A, B. Okay. I did screw something up. Let me go ahead and erase this. I was thinking squared and I wrote squared. I didn't want to write squared. Okay. There we go. All right, now we have a system of equations. Now all we have to do is solve this. Remember, substitution, elimination, or graphing. So you could go graph all three of these. I think we're going to go ahead and use elimination because I'm seeing all those C's that I'll be able to subtract and simplify this. So a little review on elimination. We're going to call that equation 1, equation 2, equation 3. So for my first step of elimination, I'm going to eliminate C from equations 1 and 2. And I'm just going to subtract those two. So this is how I'm going to write it, a little bit of a shorthand. So 4A minus A is 3A. Negative 2B minus B is negative 3B. C minus C is 0. That's what I wanted. I want to eliminate C. 32 minus 5 is 27. All right, so step 1 done. Now I'm going to go ahead and do equation 2 minus equation 3. Again, just a shorthand way of writing it. If you want to write out those equations, you're more than welcome to. So I've got A minus 9A, so that's negative 8A. B minus 3B, that's negative 2B. C minus C is 0. That's key. If you eliminated C in the first equation, you've got to eliminate C in the second equation. 5 minus 17 is negative 12. And now I'll do it all again. So I'm going to take this first equation and then try to eliminate something from the second equation as well. I got 3A and negative 3B. So I'm definitely going to have to multiply both equations by something. So let's go ahead and do this together. 3A minus 3B equals 27. Negative 8A minus 2B equals negative 12. Actually, I think I can do something else. I was going to multiply this top equation by 2 and this bottom equation by negative 3 to eliminate the b's. But now that I look through here, I think I can divide and simplify these equations all together, and then my b's will drop out. So watch what I'm trying to say here. So I'm going to take that equation and I'm going to divide everything by 3. I'll take that second equation and I'm going to divide everything by, I'm going to call it negative 2. You'll see why I chose negative here in just a second. So 3A divided by 3 is just A. Negative 3B divided by 3 is just negative B. 27 divided by 3 is 9. Negative 8A divided by negative 2 is 4A. Negative 2B divided by negative 2 is just B. That's why I did negative 2, so I can get those b's to just cancel out. Negative 12 divided by negative 2 is just 6. So if you wanted to multiply the two equations and make the numbers a little bit bigger, you definitely could have. I just decided to divide them just to make them a little bit smaller, and then pretty much the same thing. So now if I add these two equations together, I get 5A, the b's cancel out, and that equals 15. So A equals 3. So now I'll go back to these two equations that I created in this step here and plug in A equals 3 into either one of them to get B. It doesn't matter which one. I guess I'll pick this first one here. So if A equals 3, and go ahead and solve for B. So I'll subtract 9 from both sides. 18. Divide both sides by negative 3. So I get B equals negative 6. And then my last step, go up to these original 3 equations, plug in A and B into any of those. It doesn't matter which one. I think I'm going to go ahead and pick equation 2 to calculate for C. So if a is 3, b is negative 6, we're finding c, and that equals 5. 3 plus negative 6, that's negative 3. I'll add 3 to both sides, and I get c equals 8. So a little bit of a quick refresher on systems of equations, but you will need to know that to answer this problem. So 3, negative 6, 8. Let's make sure I didn't screw anything up. A is 3, b is negative 6, c is 8. Perfect. And now I can just plug in those values into that generic function. So remember, we always have a generic quadratic function, ax squared plus bx plus c. So if a is 3, b is negative 6, c is 8, that would be your quadratic that would pass through all 3 of those given points at the beginning. Of course, you can go and graph this. You can go on Desmos and graph that to just verify that you didn't make any mistakes, but I'm pretty confident I didn't. Let's just double check and make sure it's the same problem. Yep, 3x squared minus 6x plus 8. Example 5, we are going to skip. We are not going to do linear regression. So don't worry about example 5. That will not be in your problem set, and then that will not be on your weekly quiz or your tests. So linear or quadratic regressions, we're not going to deal with. On page 85 is the concept summary. So that'll summarize all the information that we talked about today. And then let's go ahead and start working through these problems. So practice problems 16 through 24. 16 through 24. We are skipping 25 because we're not doing quadratic regressions. All right. Find the vertex of each parabola. So they're giving you that. Again, the vertex you can see here. Go back to example 1 to verify or to kind of jog your memory on what it's talking about. This is all about that formula opposite of b over 2a. So for number 16, h equals opposite of b over 2a. That's huge. Make sure you remember that. That will kick off finding the vertex of this quadratic. So in this problem, it looks like a is negative 1, because remember, a is always the number in front of x squared. B is 6, because b is always the number in front of x. And c is 30. So to plug these into our formula, the opposite of b, so the opposite of 6 is negative 6. 2 times a is negative 1, so 2 times negative 1 is negative 2. So our h value of our vertex is 3. And again, to get k, all you have to do is plug that h value into your function. So negative x squared, so it's negative 3 squared, plus 6x, so plus 6 times 3, plus 30. And then just calculate this. Don't do negative 3 squared and think it's 9. Here you have to square 3 first. Then you can apply the negative. So 3 squared is 9. Then I'll multiply it by that negative 1. So that's a negative 9. Negative 9 plus 18. So that's 9. And then plus 30, that's 39. All right, so our vertex here for number 16 is going to be 3, 39. (17) Same type of problem. Opposite of b over 2a. So in this case, b is 12. So the opposite of 12 is negative 12. A is 3. So 2 times 3 is 6. So our h value is going to be negative 2. Plug in that value into your function to find your k value. So 3x squared plus 12x, negative 2 minus 5. So negative 2 squared, that's 4. 4 times 3 is 12. 12 times negative 2 is negative 24. 12 minus 24 is negative 12. Negative 12 minus 5 is negative 17. So h comma k, negative 2 comma negative 17. For 18 through 21, find your vertex, the y-intercept, the quadratic function, and use them to graph the function. So for 18, the first thing it wants us to do is find the vertex. So let's go ahead and do that really quick. Negative x squared plus 6x minus 8. So opposite of b over 2 times a. So my h value is 3, and then plug it in to get my k value. Uh, 3 squared is 9. 9 times negative 1 is negative 9. 6 times 3 is 18, minus 8. Negative 9 plus 18 is 9. 9 minus 8 is 1. So our vertex is going to be at 3, comma 1. The y-intercept, remember the y-intercept is always just that last number over there, so it's going to be negative 8. So I got my vertex, I've got my y-intercept, and now we're going to graph that function. So we'll just sketch a graph. It doesn't have to be perfect. So y-intercept is at negative 8, and then my vertex is at 3, comma 1. So 1, 2, 3, 1. All right. You know this parabola is going to be upside down like a frowny face because it's negative. That's a negative x squared. When your a value is negative, it's going to be an upside down parabola like that. So it's going to look something like this. Bam. Remember, you have that line that exists that goes through your vertex that's going to reflect the left side onto the right side. So if this vertex here is at 3, comma 1, our x value is 3, how far is that distance to get to that point, right? Well, if that x value is 3, it's going to take 3 steps to get over to our y-intercept. So I know that this other side has to be 3 steps to the right. So if our x value is already at 3 for our vertex, 3 steps to the right, that would be at 6. And then this y-intercept was at negative 8. So this other point right here would be at 6, comma, negative 8. All right, 19. Same thing, vertex, y-intercept, find that third point and graph the function. So my vertex is going to be opposite of negative 8 is positive 8. 2 times a is 2. So the h value is 4. Plug that into your function to get the k value. So it's going to be 4 squared minus 8 times 4 plus 11. Uh, 16 minus 32, that's negative 16. Negative 16 plus 11 is negative 5. So my vertex is going to be at 4, comma, negative 5. Now we got to find the y-intercept. Remember the y-intercept, super easy. You can just look at a standard function and pull it out. So my y-intercept is going to be 11. So if I were to kind of sketch this graph real quick, there's my y-intercept. We're going to call that 11. My vertex is at 4 comma negative 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So there's my vertex. Again, we've got that axis of symmetry. So we know that the left side is going to have to map across this axis of symmetry to the right side. It's got to mirror itself across that axis of symmetry, okay? We know that this vertex is at 4, so this x value is at 4. So to get back over to my y-intercept, it's going to be 4 units to the left. So I know that this other point that I need to graph this function has to be 4 units to the right. So what's the other point? Well, the vertex is at 4 comma negative 5. So if we want to go 4 units to the right, that's going to be at 8. Right? 4 already, 4 more is going to be 8. And then to go up to that point, we know that it's across that line, y equals 11. So that's that third point that I need to graph that function. And 20. We'll do one more. I think I'll go ahead and skip this one over here just because they're all 4 the same. So let's do one more, and then you can look at the solutions manual on Canvas to kind of see the idea behind 21 if you want to. But 20, same thing. So to calculate h, we're going to use that formula, opposite of b. So the opposite of 18 is negative 18, divided by 2 times a. So 2 times 3 is 6. If we simplify that, we get that h equals negative 3. And then to get k, all you have to do is plug it into the function. So 3x squared. So I just plugged in x is negative 3, plus 18x, plus 18 times negative 3, plus 10. Negative 3 squared is 9. 9 times 3 is 27. 18 times negative 3 is negative 48. So 27 minus 48 is negative 21. Negative 21 plus 10 is negative 11. So I know my vertex is at negative 3 comma negative 11. Again, to get that y-intercept, it's just the number at the end. So y equals 10. So let's go over here and start sketching this. So there's my y-intercept, negative 3, 1, 2, 3, and then negative 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my vertex. You know this parabola is a happy face because that a value is a positive. So it's going to have to open up from that vertex. So something like that. And again, we have that axis of symmetry that goes down through that vertex. So I know that the left side has to be mirrored across that axis of symmetry. So this is at negative 3. So to go from that axis of symmetry that goes through negative 3 and going right to that point, that has to be a distance of 3 units away, right? Our y-intercept, that's when x equals 0. So to go from negative 3 to 0, that's 3 units away. So this other point has to also be 3 units away. So this other point to go 3 more units away, that's negative 4, negative 5, negative 6. And then go up to that line, y equals 10. So that point has to be negative 6 comma 10. All right. Like I said, just for the sake of time, this is already getting to be pretty long, 45 minutes almost. We'll skip 21, but you can go look at that in the solutions manual. It walks you through it step by step. It shows you the graph, all that kind of stuff. That solutions manual is awesome. 22, a rocket is launched into the air. The path of the rocket is modeled by the equation that. What is the maximum height reached by the rocket in feet? Well, just like when they're talking about the maximum profit from that example in the textbook, now they're talking about the maximum height. Anytime they use the words maximum or minimum, you want to be thinking vertex. So that's what they're asking us to do, is to find the vertex. So the opposite of b divided by 2 times a, so 2 times negative 10 is negative 20. So we can simplify that. A negative divided by a negative is a positive. We can get rid of 1 0 from the top and the bottom. 16 divided by 2 is 8. So we know that our h value of our vertex is 8. So we got to calculate the k value, plug in 8, negative 10 times 8 squared plus 160 times 8 minus 100. 8 squared is 64. 64 times negative 10 is negative 640. 160 times 8, what is that? 80, 48, 128, 1280. Hopefully I didn't screw that up. 160 times 8 is 1280 minus 100. So negative 640 plus 1280, that's going to be positive 640. Positive 640 minus 100 is 540. So our vertex is at 8, 540. So the maximum height reached by the rocket, it looks like after 8, we'll call that 8 minutes, maybe. They don't tell you like a specific time frame, but the way I'd read this is after 8 minutes, after 8 seconds, whatever it would be, I'd guess 8 seconds. After 8 seconds, it would be 540 feet in the air. Yep, in feet. So the answer would be 540 feet. '23 and 24. Write the equation of a quadratic function in standard form for the parabola that passes through the given points. So this is that one where we got to take these 3 points, plug them in, create a system of equations, and then use whatever method you'd like to, probably elimination, to find out what that function is. So I'm going to go ahead and write this down so that way I can. So it's negative 1, 5, 4, 0. 5, negative 7. So now that I know those 3 points, I can go ahead and plug these into that generic function. Remember, this is where you're plugging them into the generic ax squared plus bx plus c equals y. So I'll go ahead and write that out. Ax squared plus bx plus c equals y. So in this case, a is negative 1, b is 5. So I'll go ahead and do that for the first point. Ax squared plus bx plus c equals y. Then the next one, 4, 0. So a times 4 squared plus b times 4 plus c equals 0. And then the last point, x is 5. So a 5 squared plus b times 5 plus c equals negative 7. So if we clean this up a little bit, 4 squared is 16. All right, let's start at the top. Negative 1 squared is 1. So that's going to be 1a. B times negative 1, that's negative b, plus c equals 5. 4 squared is 16, so that's 16a. B times 4, that's 4b, plus c equals 0. 5 squared is 25. B times 5, plus c equals negative 7. So all I did was plug in x, did a little bit of math, had to square one of them, and then rewrite the second term. Just make sure you're setting it equal to y. So now I have a system of equations, kind of similar to the example one I saw. I'm going to go ahead and eliminate c just because they're all 1c, so I can just subtract them all from each other. So this is equation number 1, 2, and 3. So if I do equation number 1 minus equation number 2, a minus 16a, that's negative 15a. Negative b minus 4b, that's negative 5b. C minus c is 0. 5 minus 0 is 5. Now for the second one, I'll go ahead and do equation 2 minus equation 3. 16a minus 25a, that's negative 9a. 4b minus 5b, that's negative b. C minus c is 0. 0 minus negative 7 is 7. I think I'm going to do the same thing I did before, where I'm looking at this. This is already negative b. If I went through and I divided each of these things by negative 5, I should be set up and good to go. So negative 15a divided by negative 5, that's 3a. Negative 5b divided by negative 5, that's just b. 5 divided by negative 5 is negative 1. So now with this, the second equation there, negative 9a minus b equals 7. Now I can just add these two together and eliminate b and solve for a. 3a plus negative 9a, that's negative 6a. The b's cancel out. Negative 1 plus 7 is 6. Divide both sides by negative 6, and I get a equals negative 1. Now that I know a is negative 1, I can go back to either one of these two equations. It doesn't matter which one, it's your choice. Or you can go back to either one of these two as well. It doesn't matter, completely your choice to figure out what b is. So I'll go ahead and go back to this one. 3a plus b equals negative 1. So it's going to be 3a, because I know what a is, plus b equals negative 1. 3 times negative 1 is negative 3, so if I add 3 to both sides, I'll get b equals 2. And here's the step where I'm going to take both of those values for a and b and go back to any of these three equations from the beginning. It's up to you. I'm going to hit up the first one just because, I don't know, the other two look like they have bigger numbers in them. So I'll go ahead and plug in a and b into equation number 1. So it's a minus b plus c equals 5. So a minus b plus c equals 5. Negative 1 minus 2 is negative 3. If I add 3 to both sides, I get c equals 8. So a is negative 1, b is 2, c is 8. So my final answer for this quadratic, instead of ax squared plus bx plus c, I would just plug in the numbers. Negative x squared plus 2b plus 8. We'll go ahead and do the second one as well, just because that's kind of a lot of work there. 24 is our last one. So again, just 3 points. We're skipping 25 because we're not doing quadratic regression. So let me go ahead and write down these 3 points. Negative 2, 2, 1, 8, 450. All right, so here we go. Again, I'm just going to take these 3 points, plug them into those kind of generic functions, ax squared plus bx plus c equals y, and then do a system of equations. So in this case, x is negative 2, y is 2. So we're going to do ax squared plus bx plus c equals y. right? X is negative 2, y is 2. Same thing with the next one. Ax squared plus bx plus c equals y. And then with the last one, ax squared plus bx plus c equals y. Now let's go ahead and just kind of simplify this a little bit. Negative 2 squared is 4. B times negative 2. I just like to rewrite that so that coefficient's up front. Plus c equals 2. 1 squared is 1. B times 1, that's just b. 4 squared is 16, so that's 16a. B times 4 is just 4b, plus c equals 50. And again, just like the last two we've seen, I'm going to go ahead and eliminate c, so basically do the exact same process. If you wanted to get fancy and eliminate a different variable, you totally could. I'm just going to eliminate c. So we'll call this equation number 1, 2, and 3. I'm going to go ahead and clean up my workspace here a little bit. All right, so equations 1 and 2, I'll go ahead and subtract them. Caden, turn that off. Subtract equations 1 and 2. So 4a minus a, that's 3a. Negative 2b minus b, that's negative 3b. C minus c is 0. 2 minus 8 is negative 6. And then again, just like the last kind of couple examples, we'll do equations 2 and 3. I'll subtract them as well. So a minus 16a is negative 15a. B minus 4b is negative 3b. C minus c is 0. 8 minus 50 is negative 42. In this case, I don't have to multiply or divide by anything because I think if I go ahead and subtract these two equations, my b's will cancel out. You're more than welcome to subtract them right off the bat, but some people struggle with negative 3b minus negative 3b. So one thing you could do is you could take either one of these equations and multiply it by negative 1, just to have a positive and a negative b. So if I did that, that would be negative 3a plus 3b equals 6. The second equation I have is right here. So negative 15a minus 3b equals negative 42. Now if I add these two equations together, I get negative 18a. My b's cancel out. 6 plus negative 42, that's negative 36. And solve for a, divide both sides by negative 18, and I get a equals 2. Go back up to any of these four equations, right? These two are the exact same thing. These two are pretty much the same. You just multiply them by negative 1. But you can go back up to any of those four equations and plug in a equals 2 to get b. So I think I'll go back up to this original one. So it's 3 times a minus 3b equals negative 6. So I'm going to subtract 6 from both sides. Divide by negative 3. And I get b equals 4. And now my last step, go back up to any of these three original equations. It's up to you. Plug in a is 2, b is 4. I think I'll pick the second one there. That looks like the easiest. So a is 2, b is 4. Plus c equals 8. 2 plus 4 is 6. So I'll go ahead and subtract 6 from both sides. And I get c equals 2. So I'm ready for that generic function to plug in those values of a, b, and c. So remember that generic quadratic function is ax squared plus bx plus c. So in this case, a is 2, b is 4, c is 2.